Hi everyone, let's go ahead and get started with the sequence, repetitions and random numbers in a NumPy. So sequence is like you are generating a list of the numbers. A repetition is like you are repeating a set of numbers to generate an NumPy array. We will first see here arrange. So arrange function is used to get the evenly spaced values within a given range. For example, if I say here arrange and you specify here values inside arrange like 1, 5, it is gonna give us, alright, it is going to be the np.arrange here. So np.arrange here, that should be AAR, it's like this. So the np.arrange, that means it is going to give us an array, a range array. So 1 to 5, that means it is going to give us a value between 1 to 5, a evenly spaced value, and this last value will be ignored here. 1, 2, 3, 4 is included there. Similarly, if I say here 11, then you will get a value from 1 to 10. Similarly, you can define here a data type to get your values. I say here integer or I say here a float. So if it is a float, you will be getting here a float. Otherwise, you can say here str. Seems like str is not available there, but yes, for float it works there. But if you are not satisfied with this range of values, you can also specify here the steps in which you want to generate. So the third parameter defines here the steps which you need to do here. If I give 1, then it is going to give us the same result what we got earlier. The reason is here, step 1, that means it is going to keep the difference between these two consecutive number as 1. But if I say here 2, it is going to keep the difference between these two consecutive number as the 2. So it starts from the 1 and plus 2 is the 3 plus 2 plus 2, and if it add 9 plus 2, then it becomes 11. But as we know that this does not include 11, that's why we are not seeing 11 here. Similarly, you can put here a 5 as well. So you will be seeing here 1 and 6 only, or whatever the numbers you put there, accordingly you will be getting here a range of values there. The another function which we are going to see here, linspace. A linspace is linearly spaced values. Again, in this we define there numbers between starting and end numbers, and then we say that how many numbers we want. I'll tell you the difference. For example, if I ask you to generate, if I ask you to just change this range to linspace, then see what happens here. You know, by definition it seems linspace and a range is same, but actually these are not. The difference is here, if you define here a 5, that means it is going to generate values between these two values, but the difference between these two consecutive value will be 5. But in linspace, it is going to generate values between these two, and it will include the last value, and another difference is here this one. So here we define that how many values we want. Earlier we were saying that what should be the difference between two consecutive number, but here we are saying that how many numbers we want. I said that I want a 5. So this line of code gave me a 5 number, 1, 2, 3, 4 and 5. And then these numbers are evenly spaced. Another difference between these two are, here you can control the difference between consecutive numbers, that means the gap between the consecutive number, but you cannot control how many numbers you want. In a linspace, you can control how many numbers you want, that means the size of array you can control, but you cannot control the differences between these two values. That's the major difference here. If you say here a 50, you are gonna get here a 50 values between 1 to 11 are evenly spaced values. Similarly, if you put here int, now you will be seeing there all the float values got converted into a integer numbers there. Alright, let's go ahead and see how we can use the random. So for a random, we need to import random first of all, and then we can generate the random values. Import random, alright, or from numpy import random. So the both works in the same way. Alright, so I'm just gonna remove that one. I got here a random. Now you put there a random, and then you hit here shift and double tab, you get the definition of the random. So it says that the random number generation, and it takes here, it says that these are actually generator, that's been the algorithm which generates the random numbers. And then finally you come to the end of this somewhere here. You see that these are the APIs available into random, like rand, randn. These are uniformly distributed values, a normally distributed value, uniformly distributed floating point numbers, or something like that. So all these are available here. These are the distributions which you can generate by using the random numbers into a numpy there. Alright. So for example, if I say here like random 1 to 10, alright, okay, random dot rand int actually. So it is going to give us the random numbers between these two values 1 to 10. Every time I run it, all these values will be in between 1 to 10. If I give here 1000, there is the probability that you will be getting the values between 1000 to this. Sometimes you may ask that how would you get the float values? So like let's say if you want to the float values, a random float values between 1 to 1000, you can simply either divide it by 100, you will start getting here a random float values. Similarly, you can get the normal distributions or uniform distributions as I said earlier. Let's go ahead and see the other functions like range function, then zeros and ones functions we will evaluate here. In the range function, range is something where you say that what is the range you want between these two. So this range is like a range. Alright. So earlier we saw this one. This range is also in the same way, but here it does not return any array, because this one is not the array of range. This is just a iterator there, a range. If you want this as the array, then you put here np dot array. It's something like this. So in the similar fashion, you will start getting a range and range in the same way. So earlier a range was like the array of a range there. Let's go ahead and see zeros there again, np dot zeros. So this comes into the definition of repetition. There was the generation and the repetition. So the repetition is something I'm saying that generate a list of zeros which I defined here rows and column. So it says that there is 1 row and 5 column. There is the 2 row and 5 column. And here it is a 5 row and 5 column, 1 2 3 4 5, 1 2 3 4 5. Alright, so it has total 5 rows and 5 columns. That's the zeros there. Similarly, you can do with the ones as well, like np dot ones. Here if you define here only 1, it's going to give you a one-dimensional array. If you define here a 5, it is going to give you a one-dimensional array, a length of 5. Similarly, if you say here 5 cross 5, a two-dimensional array, But again, if you make it something like this, it is going to give you a 3-dimensional array. You can check the shape of generated array. It says that 5 cross 5 and there is the 4. Alright. Perfect. In the last one, which we are gonna see here quickly, np.tile and np.repeat. Let's say you have here np.tile. In this I have these values and I want to repeat these similar values multiple times. So here I say here 2, that means this similar value will be repeated 2 times. If I say here 20, the similar value will be concatenated 20 times here in 1-dimensional array there. Alright. Similarly, there is np.repeat there. So this repeat also does the same thing here, but the difference is here tile takes this whole value and then concatenate this whole value as many as number you provided here. But in case of repeat, it is a little different. In case of repeat, it repeats these numbers as many times you define it here. That means this repeat 1 2 times at this place itself, and then 2 times at this place, and 3 at this place. For example, if you give here a 20, so this 1 will be replaced 20 times first, and then 2 will be replaced 20 times first, and then 3. That's the major difference between repeat and tile. Alright, so this is all about in this lesson. Thanks a lot for watching this. I'll see you next one.